Okay, now we're going to be talking about section 3.2, ratio and proportions. These are very similar to problems we faced before. It's just a new way of saying division. A ratio compares quantities by division. So for example, the ratio A to B, when we see a ratio that says A to B, can be expressed as written, so when it's written A colon B, that's identical to saying A divided by B. That's real important to note that the number on the left has to be the number on top. The number on the right has to be the number on the bottom, or else it'll be incorrect proportion, or incorrect ratio. Here's an example. In the class there are 15 girls and 20 boys. Find the ratio of boys to girls. So we have to make sure and get the number of boys on top, because it's boys to girls, so boys colon girls. So we know the boys has to be on top, the girls has to be on bottom. Boys, there's 20 boys, 15 girls. Anytime you have a ratio, you also have to simplify. And when we simplify, we don't necessarily need to get a mixed number or a decimal, but we do like to get to the most reduced fractional form as possible. In this case, it's 4 to 3, and we write that as ratio 4 colon 3. Now, a proportion is a statement that says two ratios are equal. So a proportion is going to be saying the fraction on the left is equal to the fraction on the right. One way we can simplify this is by getting rid of the fraction on both sides, meaning cross multiplication. And here we get AD, which is the cross product of A and D, is equal to the cross product of B and C. There we go, is equal to B and C. So this here down here is identical to saying this up here on top. And here's again just what they said. The cross product principle for proportions, AD is equal to BC. One special note is B or D cannot equal 0, because if they equal 0, then these numbers are undefined, because we know we can't divide by 0. Here's an example of proportion. They want us to solve it. So we know from working all of our problems so far, when they want us to solve for a variable, they want us to isolate it and get it all by itself on one side of the equation. So this one may look a little difficult, but it's not. All we got to remember is we can use that cross product principle of proportions and say x plus 3 times 3 is equal to 6 times 2. That's what they did here. They used cross multiplication. Then they distributed the 3, and then they moved the 9 over. Then they got x by itself divided by 3, and x equals equal to 1. And of course, we know how to check our answer by plugging 1 in here and seeing if this is true. So last section we talked about word problems. When you're dealing with proportions and ratios, you're going to get a lot of word problems. Because that's one of the simplest forms of word problems is ratios and proportions. So let's go ahead and look at some examples. If the gas bill for an apartment with 800 square feet is $45, how much would you expect the bill to be for a 1,000 square foot apartment? So these are actually starting to be problems that we can use in our real life, right? So we know that the gas bill x, we'll say x is equal to the gas bill for a 1,000 square foot apartment. X is our unknown variable. That's what we're trying to find from our problem. When we set up the proportion, we know that an 800 square foot apartment costs us $75 for our energy bill. If we use proportion principle, we know if we have a 1,000 square foot apartment, it's going to give us some utility bill. The important thing to note here is that the square footage has to go on top on both sides, and the dollars has to go on bottom on both sides. It would also be okay if you put the dollars on top, if you put them both on top on both sides, and the square foot on bottom on both sides. That's another way you could have written this out. So if both these were flipped, both sides were flipped. And then you can go ahead and solve it. We know how to solve for x. We multiply, we use a cross product principle on both sides, and we end up getting 800 times x is equal to 45,000. Then we divide by 800 on both sides, and x is equal to 56.25. So the main things to note here are a ratio compares quantity by division. So it's just division. It's just a different way of writing division and saying division. A proportion compares two ratios. So a proportion has an equal sign in it, and you have to usually solve for an unknown variable in your ratio. Um, and then the last one is the easiest way we know how to solve a proportion is by using the cross product principle. So go ahead and try the problems out, and good luck.